All right, this is part 2, and we'll work until it quits. If it quits, automatically you know there's a part 3. Okay? All right. So, first of all, let me ask you this. What has more energy, do you think? Just intuitively, what has more energy? A or B? What has more energy? A or B? A. And just think of it this way. Think of it as a string. What has more string? A. More string. Right? Now, so this is wavelength. The distance between those peaks is wavelength, right? What has the larger wavelength, A or B? B has a larger wavelength, right? What has the greater speed? Think about what you just said. Does the speed of light change? No. Speed of light doesn't change. Okay? It stays the same. All right, let me ask that question again. Which has a greater speed, A or B? Same, okay. What has a greater wavelength? B, you said that, good, excellent. Just want to see if you forgot. What has a greater frequency? And what is frequency? Yeah, the wavelengths per second, okay? What's another word for wavelength? A cycle. A cycle. One cycle. Because a wavelength could really be this too, couldn't it? Couldn't it? Couldn't it be this? Right? Same thing, right? A cycle. Right? Right? Repetition. Okay, so let's see if that fits into our thing here. You have C equals lambda nu. So as this is constant, let's just pick numbers. Let's say this is 100, okay? Well, let's say this is 1. That makes more sense. Let's say that's just 1, okay? Let's say this is 100. What does nu have to be? What must nu be? This is a constant. These two can vary. So what is nu going to be? 1 over 100, right? Now let's increase lambda to 1,000. What's happening to nu? Is it becoming greater or less? It's becoming less. So 1 over 1,000. So limits, did you do limits yet? As lambda approaches infinity, what does nu approach? What is it? It approaches what? As, well, think about it, girl. Think about it. As this blows up to infinity, what's this going to do? Is it going to become larger? Is it a negative number, or give me a number that it approaches? Give me a number that it approaches.
1 over infinity.
Give me a number it approaches.
1 over infinity.
What's that called? 1 over 1 over infinity. What's that called?
1.
Right? Does it approach 1 over infinity? Is that really 0? Right? 0. So as lambda approaches infinity, nu approaches 0. Does that make sense? Am I being clear? Am I being clear, or am I being, just call me Mr. Mudd? Am I being clear? All right, good. So, believe it or not, that's it. Got to practice some problems, but that's it. There's nothing else. Now, there's another equation that I kind of put on the board, but let's talk about this first. What's the amplitude? Look that up. Look up amplitude and tell me what amplitude is, which you should already know, but I'm giving you a break. What is amplitude?
Objective measurement of the degree of change.
Yeah, it's the height of the wave. Right? Is it this height or this height? And what's the middle line called? So that's what I want you to do.
Average pressure.
Average pressure? How did you come up with that? Well, you look up something on Wikipedia or something?
No, it's not Wikipedia. It's what is amplitude. And it has a
No, I'm not like making fun of you with Wikipedia. I love Wikipedia. It's go-to, man. I mean, unless you're, trying to diffuse a nuclear device, I wouldn't look up Wikipedia. But I mean, for just basic having some fun, Wikipedia is pretty good. That was actually pretty funny, wasn't it? It was good. Yeah, I wouldn't use it for, diffusing a nuclear device, but yeah, it's good. Did that just go off?
No.
Okay. So anyway, this is the nodal. That's the nodes. That's the nodal line. Okay, it's the nodal line. It's where the point of inflection, right? Where you get changes, right? Right. So what's the amplitude? From the middle, from the nodal line to the upper? Yeah. You get it? Okay? All right? All right, so. Right. That's it. It's really that easy. Now there's another equation, a proportional equation. E equals h nu. What's h? Planck's constant. Anybody know what Planck's constant is offhand? 6.63 times 10 to the negative 39 or 31, something like that. Is that right? Can you imagine if I got that right? I'd have to go be like Dumbledore and take some of my memory out. That would be a little too weird. So can you look that up? Look up Planck's constant, see what it is. I can't believe if I'm right. That would be too weird. I'm voting for negative 31. 6.63 times 10 to the negative 31. That's my vote. Planck's constant.
6.6260704 times.
All right. We're impressed, but round it to three saving figures.
6.63 times 10 to the negative
31?
4.
Oh, 34. Now, what's 1,000 among friends? All right, I was off by 1,000. Okay, so, right. So, that's it. Yeah, are we okay with that? How do you feel about it now? Feel all right? Yeah, you're okay? Yes?
Are we going to have this kind of questions in the test?
Yeah, of course.
So we're going to solve for the speed of light,
Yeah.
the frequency.
Yeah. I mean, yeah. And you could actually go, if you wanted to go a little crazy, like go a little bit nutty, and say nu equals what? E over h, right?
Yeah.
And then you could go C equals lambda E over h. You want to go really crazy. And then you could fit in for AE and do some other things, and all of a sudden you have the Schrodinger equation. No, not that! Yeah, cool, huh? Yeah. All right? All right, so end of part 2. Did we do it all or what? Did we do it all? Are we all right with that? Yes? Johnny, Mr. Excitement, are you okay? You look like you're ready to kind of do battle there. You look like you're getting mentally prepared. Yes?
It's cold.
It's cold, so we'll turn it down. Don't. Oh, you gave it back to me. Okay. End of part 2. I know. I do feel like I'm in New Jersey in the winter, and there's no heat in the classroom. Here we are in Cambodia, and it's 90 degrees outside.